Dear students, we have already finished unit number 1 and today we have to take up unit number 7 known as Properties of Matter, and it carries 10 marks. And in this unit number 7, it consists of 4 chapters. The first one is Elasticity or Elastic Behavior of Solids, and chapter number 2 is known as Hydrostatics, that is fluid at rest, and third one is hydrodynamics, that is fluid in motion, and chapter number 4 is known as thermal properties of matter. So let's start from chapter number 1, that is elasticity. And before going through this elasticity, first we have to define some important terms related to this elasticity, and without knowing these important terms we can't proceed this elasticity. So let us define some important terms. So first we have to define these two terms, that is deforming force and restoring force. So let us take an example. So in this figure, an external force amako. Let F represents a force applied on a body so that the body is moving with some acceleration A. When the body is the force pire, the body is at lower saber with some acceleration A. This is the period force, deforming force cover. And this force is not a deforming force. Then what is meant by deforming force? When deforming force I tell you kawudagi fighter body to give shape and size change lakadaba. Motion produced over the deforming force kaude sagi magi body to give shape and size change to one force to deforming force kawaneba. Say for example, let us consider a spring ama lower zero, whose one end is fixed to a rigid support. Bagi machine amadi fixed over, and let a load or a body is attached to the other free end of the spring. Spring to gi atop magi free end to the koina koigi body ama yanzalaba ko load ama yanzalaba. Then what will happen? That spring will be elongated. That is, the length of the spring will be increased. So this load, that is the body attached to the other free end of the spring, is said to be a deforming force. The body to be weight mg or wz weight deforming force deforming force motion produced over force to nate body to give shape and size change on force to deforming force going. Then what is meant by restoring force? Restoring force it may be defined as the force set up in the body itself in order to regain the original configuration, that is the shape and size of the deformed body. For the deformed body magi shape and size change to matungda deforming force the hand original shape and size the batting power force to ni restoring force. In this particular example, when the load attached to the other free end of the spring is removed, then the spring can regain its original length. So that force helps in order to regain the original length of the spring is called restoring force. If there is a deforming force, then automatically a restoring force will be set off in the body. Deforming force ama in the body the body do the masa restoring force ama set up to. So let us define what are deforming force and restoring force. So deforming force may be defined like this. It is the force which, when applied on the body, produces a change in the shape and size of the body. Body the force force body shape and size change to force to deforming force. Then restoring force may be defined like this. It is the force set off in the body itself in order to regain the original configuration, that is shape and size of the body after the removal of applied deforming force. Restoring force haigana body to the pisaliba deforming force to akoina laktuo kanda body dugi masamakta set up tawjarakpa develop tawjarakpa force karamba force sagi original configuration, original shape and size of the body do amuk hanjanaba honabada piba force to ni akoina restoring force haisni. And next we have to define another term known as elasticity. Elasticity the karino define tawji, and it is the property of the body due to which it regains its original shape and size after the removal of deforming force. Akoina deforming force laktuo matungda body duna magi hana leizeramiba shape and size ta hanjanba ngambagi magun duni property duni akoina elasticity haisna. Aduga elasticity have a property je utpa adi laibang ngam body duna akoina elastic bodies kawani. So we may write like this: the bodies which exhibit this property, that is elasticity, are called elastic bodies. For example, simple example like rubber, spring, etc. So then next term is plasticity. Plasticity haragana karino bagi original shape and size hajan bangam da baduni. So we may define like this: it is the property of the body due to which it cannot regain its original configuration, that is shape and size, after the removal of deforming force. Those bodies which exhibit plasticity are called plastic bodies. Sigi plasticity have a property like the bodies in the plastic bodies cover. For example, mud, wax, etc. When the like homes mesal laga thaduk bada amung magi hanagi shape and size la pangam de aduna mukoi jokoina plastic bodies manung sali mud kumba wax kumba je kon. So next we have to define an important term known as stress. S-T-R-E-S-S. And see stress we define tawji and akoina uji do when a deforming force is applied on a body, then its original shape and size should be changed. When deforming force ama piragadi body to get shape and size change so at the same time the restoring force ama develop the body to the in order to regain its original configuration. And when stress haragadi is defined the way it is defined as the deforming force per unit area of the body. Body dugi unit area the labor force deforming force to stress height is it. So mathematically we may write like this: stress height are the deforming force divided by area, that is F by A. So here F represents deforming force and this A represents area of the body. And again, deforming force should be equal and opposite to restoring force. Deforming force ka restoring force is a value di samanani aduga direction di opposite oineba. For example, sida koina spring mas mai lawre spring ji akoina stress or sing to over applying some deforming force. Sida pisal is a deforming force ni ko sida apply to deforming force eraba at the same time restoring force ama set up tor kaneba in the opposite direction the F the asna restoring force eraba akoina spring ji sing to kan the pisal force to na deforming force, that is the deforming force is acting downward in this particular example and the restoring force is acting vertically upward. Aduna ani is equal and opposite way ganeba. Restoring force na direction amma da saladi deforming force na mari opposite direction la gani, but they have the same magnitude value di samanani. Aduna deforming force ki mauta ko na restoring force har su yai stress equal to restoring force per unit area. So the SI unit of stress should be Newton per meter square. When stress height the force divided by area force the SI unit of force the Newton later aduga area gi SI unit na meter square. So Newton per meter square ani. Then its dimensional formula is dimensional formula di kamaina pirani force ki dimensional formula di last time we have already discussed MLT minus 2. sina force ki dimension formula ni area di L square ni m to the power 0 L square capital T to the power 0 aduna force by area ani je divide tawro adu di sita ni m L inverse T minus 2 sigi m L T minus 2 da L square no sumai divide la ka tu ni adu tar sigi L amaga cancel tawrani sigi L je denominator level L je numerator the poradi magi power je minus 1 la ne L inverse la ni aduna dimension formula for stress height di m L to the power minus 1 capital T to the power minus 2 sumai pirani aduna exam da magi definition hang bayai aduga magi dimension formula adu magi unit moising je adum hang bayai